Prediction lines are beams drawn to show the trajectory of a given projectile. Recently, I figured out how to create a trajectory line that can be used to calculate the trajectory of a 2D character's jump, which can make for some interesting ideas in game development. So today, I'm going to walk you through the process to making one of these, so you can experiment and hopefully push this concept even further in your own projects. Suppose we have a functional character. We'll use this Mario sprite I made a while ago. Mario can run, jump, crouch, all that jazz. And we want to predict how far and how high he can go in one massive leap. This is assuming no acceleration is applied while he's in midair. We'll also need one of Godot's line 2D nodes and a collision shape 2D to use as a collision test object. To accurately predict the jump, we'll need to obtain Mario's max speed, jump force, velocity, and gravity values. Once we've collected all the necessary information for our prediction, we'll have our test object simulate the player's jump, and we'll use a for loop to adjust the points from our line to match its trajectory. Depending on the context of the project, you may want to limit the amount of times the line is drawn. To do this, we'll add a maximum amount of times we're allowed to adjust the line. Make sure you have the movable object you want to track in the viewport. Mine will be this 2D character sprite. Let's also not forget to add the floor. Let's go ahead and give our character a script. And the cool thing about the character body 2D node is that there's already code written for a basic platforming prototype, so we don't have to write anything just yet. For demonstration purposes for this project, I'll be spawning lines whenever I press the spacebar, so I'll create a separate scene with all the elements we'll be using to create the trajectory line. If your goal is to have the line follow the character, you can attach the line directly to it, but for this project, to prove the accuracy of the line, we'll be spawning a line globally using a new scene. Let's add a line 2D to the scene, and we'll need to create a test collision object, so grab a character body 2D. Make sure it's a child of the line 2D node, and let's add a collision box to it. This is optional, but if you have an endpoint sprite, you can attach it to the collision box to indicate visually that this is the endpoint of the trajectory line. I'll use this bright Godot icon for that. Let's give our trajectory line a script, and let's also quickly rename our nodes so we can easily reference them later. And finally, we'll adjust the collision masks of the character and test object so they can't detect each other. Alright, setup is complete. Now let's program the trajectory line. Alright, so inside the line 2D script, we're going to need a few variables. Let's create a maximum points variable. I think 70 will be a good starting point. This is optional, but you can make max points an export variable for easy access later. Let's get a reference to the collision test box. And let's create a collision and line position variable. The collision variable will act as a boolean that lets us know if the test object has hit something. If there's no collision, kinematic 2D won't be returned and the collision won't be valid, but more on that later. Cool, so to get this up and running, we're going to need two main functions, a line refresh function and an update trajectory function. Let's start with the easiest and create the refresh function. This function restores the line to its default settings. First, call refresh on ready, and now let's give it some instructions. We're going to clear any existing line points with this built-in clear points function. Let's also set the line position to a character's position. Let's set our test object's velocity to 0, and let's run a for loop, adding as many points to our line as max points allows. Let's set our test object's position to the line position, and finally set collision to null, as we won't need it till later. During a refresh, I prefer the line to be invisible, so let's set visible to false. Now, to update the trajectory, we're going to grab the direction of the character. Mine is a character body 2D, and therefore doesn't flip horizontally. So instead, I have a variable that dictates which direction I want the character to behave in. We're passing that direction in here. Let's get the jump force. This is the velocity value you set the character to right before a jump. We need the character's gravity, the delta value, the character's x velocity, and finally the starting position of the character. If your line is a direct child of the character, then you won't need this last parameter, as the line will follow your character no matter what. Now, let's set the line position to the starting position, which should be the character's position. We want our test object to start from the position of our character as well, so let's set its position to line position. And now we begin the prediction. Set the test object's velocity to the jump force. Let's check which direction the character is pointing. If it's right, we'll set the test object's velocity to negative character velocity, and the opposite if it's left. Next, let's handle the line. Create a for loop under getPointCount. Then we'll check if collision is false. If it is, we'll add our test object's velocity y by gravity times delta, similar to how it's done in our character script. Let's add a point at our test object's position. Let's also set our collision variable to what gets outputted by our test object's move and collide function. And finally, let's set the line's visibility to true now that all the calculations are finished. The last thing we need to do is connect these functions to the character. This part is really context dependent as different games have different needs, but let me quickly go over what you can do to set this up. In our character script, we're going to first preload our line with the following code, then spawn it into the world. We'll be creating a variable to use for preloading the scene called lineScene, and one for instantiating the line called trajectoryLine. And this line of code here spawns the line into the map. If your line is a child of the character, then it'll already be in the map, so you can skip this part. In your physics process script, I forgot to mention this earlier, but make sure you add the bindings for both spawning the line and jumping. And make sure the jumping binding is any button except for the one that's being used to update the line. In this case, my update line check runs on the spacebar, so I changed my jump button to the up arrow. And finally call update trajectory if the spacebar has just been released. And we're done. When you press the spacebar, a line should spawn predicting your character's jump velocity, assuming you don't stop midway through the jump. I'll have the code up on my GitHub page if you guys want to play around with it. Be sure to leave a like and a comment down below about what you guys want to see next, and I'll see you guys next time. Bye bye.